All right, welcome back to another episode of Modern Cyber, coming to you for the last time this year from the sidelines of Forward CloudSec 2025 here in Denver. And as with the previous episodes that we've recorded live here, I have the opportunity to sit down with one of the speakers from the event, talk to them a little bit about their research, what they learned, any of the lessons they could share. I'm delighted to be joined today by Dhruv. Dhruv, thank you so much for taking the time.
Thank you for having me, Jeremy. Yeah.
My pleasure. For those who don't know you, why don't you just take a second, tell us a little bit about your background, how you got started in cybersecurity.
Right. So my background is normally from the financial services world in London, mostly. And before that, bit of sysadmin roles and Rackspace and companies like that. So I hadn't realized until I looked at cybersecurity specifically that I was already good at it.
Okay.
It's sort of a given. You have to be good at it in sysadmin and financial services roles.
Yeah.
So when I looked at security becoming a specialization with the adoption of the cloud, I tried to move laterally in one of the organizations I was working at the time, and they were very happy to have me.
Awesome. I'm curious about that background in financial services. Financial services is one of those things that like everybody hears about, and obviously we all know our banks, or we mostly use banks, right? It's one of these industries that's often, whenever people say, oh, like an industry with high regulatory compliance requirements or a lot of regulatory oversight and very, very sensitive data, everybody says, first three things people say are like financial services, healthcare, government, right?
Yeah.
From your own experience working in financial services, are financial services companies different from other kind of companies?
Yes, they are. Okay. They have very different, of course, the regulatory pressure. To give you an example, I used to work, before I went working for a bank, I used to work for a market data feed company.
Yep.
So we were supplying tick data, stock market, and several other classes of assets.
Yeah.
So you can imagine if we supply the wrong data, it will be an international turmoil in the market.
We'll make like money decisions based
on, and everything was tuned down to the milliseconds. Yeah. So it had to be extremely robust.
Okay.
With latency guarantees given us SLAs out to other investment banks.
Okay.
So it's pretty serious business.
Okay.
So these days, for example, I don't see people caring about latency that much in the cloud.
Yeah.
What that sort of a world needed.
Yeah, we've sacrificed latency for eventual consistency, right?
Yeah, and that kind of a thing. And you'll see that the companies like Bloomberg, Thomson Reuters Financial Risk, Refinitiv, etc., most of the core data feed hardware and software is still on-prem for them.
Yeah.
And if you talk to any like hedge fund or investment bank, they are attached directly into the exchanges switches for the low latency.
Yeah.
So it's a very, very different world, not necessarily visible to anybody on the outside unless you are on the inside. Yeah. That's when you see the real protocols they use and that kind of a thing.
Are they different protocols?
Oh yeah, they are very different. They are extremely efficient because you have to pass in so much data in the minimum amount of time. So they do away with like excessive syntax.
Okay. So I mean, like TCP/IP is not like the core underlying.
Not for market data, is UDP.
Okay.
Yeah. So So because you can't wait for an acknowledgement to come back.
But it's in UDP. Like, sorry to interrupt, but when I think about UDP, I think I again kind of think of eventual consistency and like, it might have higher throughput performance, but I don't. To your point, like I don't have that acknowledgement, so I don't know for sure that something has gone through.
So in those architectures, you would have multiple streams and you'd be sure that, okay, well, if not there, then on the other one, it would have made it through.
Okay.
So that's point one. Secondly, the tick data was like changing every 4 milliseconds and your decision making usually would take longer than that. So you would catch on the next one anyway.
Yeah.
And finally, there was some sort of a checksum built into a custom UDP protocol called Fix as well. So you would know if something went amiss and so on. So they basically re-implemented some of the TCP in a very lightweight application layer protocol, but working on UDP.
Okay.
The other thing about the specialized hardware was that you would have over-provisioned bandwidth there. So and we would be monitoring for UDP packet loss. Switches can measure that. So we would be keeping an eye on those monitors, whether there was any loss.
Yeah.
We would be running at zero loss.
Yeah.
This is not the big internet, right? This is private cables patching directly into the exchange.
Yeah.
And you can monitor them. Yeah.
So it's interesting. I mean, it's almost this like parallel infrastructure that a lot of the rest of the world doesn't really know or use. And there. And so I'm kind of curious about the macro question about like, well, why do we hear so much about financial service companies moving to the cloud then if you've got all this like parallel infrastructure that's built up over the years?
Yes. So that's the other side of financial services, like retail banks.
Yeah.
They have no requirement for all of these low latency kind of things. I mean, if you make a transfer to someone, your SLA is like in 300-400 millisecond range. If that, so
it can transfer to somebody, let's say over like, just kind of like not a Venmo, but, a service like that, that's, transfer from my personal account to your personal account. And it happens within a few minutes.
And you'll be happy, right? Yeah. So they don't need all this throughput and low latency. For them, it's okay to move to the cloud.
Okay.
Secondly, most of retail banking is just forms and websites and doing various things. And with the largest banks of the world, they are still running mainframes, and there are several layers of APIs built on top of it. And those API layers have now moved to the cloud.
Okay.
But for banks which are like more than 200 years old, they have so much record and data, they can't possibly move off those mainframes, which are in bunkers in the UK.
Yeah. I've had this argument with somebody not too long ago, and I kind of, not an argument, but just kind of an opinion that I had and I shared with somebody, and they kind of pushed back a little bit. And I said, like, look, at the end of the day, we do very little with cash anymore, right? Financial service companies are primarily data companies. And they're about storing, like my ones and zeros and your ones and zeros, and protecting my ones and zeros and making sure that I have access to them, and hopefully nobody else does who isn't meant to, and that I can use my ones and zeros in exactly the way that I choose to use them. Am I wrong to think about financial service companies that way?
No, but there's more that goes on behind the scenes. Banks are heavily regulated. What does that mean?
Sure.
So a real bank is able to offer a credit line.
Yeah.
Right. If a bank can only hold money, they are not really a proper bank, but they are working their way towards having such a large amount of capital that they can take on some risk.
Yeah.
So banks have to run a nightly calculation on how much risk they have taken on during that day, and they can't exceed a certain threshold set by the regulator.
Okay.
And these reports have an SLA with the regulator.
Okay.
They have to run on time and so on.
Yeah.
So there is the mission critical infrastructure of risk calculation in a bank.
But again, when I hear that, I'm like, this is a data problem. This is not like...
Yeah, true. But a lot of people, since we are in a cybersecurity conference, I've seen some of the best pen testers on board with banks. They really know what they're doing at every layer of the stack.
Yeah.
So it's crucial that people are not able to just bypass MFA, etc. in a bank.
Yeah.
Even in the login security architecture, I'll give you an example. For example, if you log in into a bank just to check balance, the bank may not ask you to use your bank authenticator device or 2FA, if you will. But if you add a new payee, they ask for re-authentication or some special code, etc. Right? So all of this is designed by very specialist architects in a bank, and then all of this has to be pen tested.
Okay.
Before it goes live.
Does all of it have to be signed off by a regulator?
No.
Okay.
This is signed off internally by C-suite executives. Okay. I suppose they are liable or not. I don't know.
Yeah. Okay.
But they take their job very seriously.
Fascinating. I mean, all of this from my initial question, are financial services companies different? I think it's eye-opening for a lot of people, probably myself included, obviously, to think about what all goes into these types of organizations. Let's change gears for a second. What was your talk on here at Forward Cloud Tech?
I think it was titled IAM Roles Anywhere, now for everyone with Let's Encrypt.
Okay. What was kind of the background and the basis of the presentation?
So I personally am a big fan of asymmetric cryptography.
Okay.
The IAM Roles Anywhere is the AWS service which lets you use certificate authorities and certificates to get a role back from AWS, a session token which is connected to a role. And I had been exploring the idea for 8-9 months now, and we are actually using this in production for about 6 months now. What we've done is that we have some workloads with specialists, AI came along and everybody got interested in GPUs. So we wanted to run some experiments. by running our own small little models.
Okay.
So we went to a specialist GPU provider, but a lot of the telemetry data we have is in AWS S3 buckets.
Okay.
And so we wanted a cleaner way of accessing that into this random GPU provider that we have. Okay. So we were looking for a more elegant method than static credentials.
Yeah.
So that's where it all started. Okay. And then I don't know how and when exactly I was able to connect the dots that all AWS IAM Roles Anywhere needs is a public key infrastructure CA, PKI.
Right.
Let's Encrypt happens to be one.
Yeah.
I can easily give these GPU machines, which are just Linux machines, right? They can easily get an identity for themselves from Let's Encrypt, and I can use the same identity with AWS. Job done.
And so that identity that you're using, let's say outside of AWS on these Linux-based hosts, is it using kind of like the AWS command line tools to then do things like session management and obtain these credentials?
That's correct. It is, yeah. It's very transparently integrated into their SDK.
Okay.
But that's the heavy lifting AWS have done for you already.
By providing the certificate authority infrastructure and then providing the ability for you to kind of like access these roles externally, or what do you mean?
The latter, yes.
Okay. For
the former, they say that you could either use AWS private CA.
Okay.
Which is I think, I don't know, $400 a month or something like that. I'm horribly wrong there, but
sure.
Or you could upload your own CA certificates.
Okay.
Which is the option I chose.
Okay.
It wasn't so much about not using an AWS service. We are an AWS user. Another service wouldn't have mattered.
Yeah.
But I am more of I like interoperability and I like to prove interoperability.
Okay.
So for me, not using the built-in PKI was a win.
Okay.
Because that means I'm using a neutral protocol, like Let's Encrypt uses Acme.
Yeah.
If I can tie in an Acme issued certificate and get it working with the cloud provider of my choice, I feel much more safe and insulated from choices I may have made today, but I would not make again tomorrow.
So in that scenario, let's say worst case scenario, some government authority shows up to Amazon with a subpoena and says like, hey, Dhruv is subject to whatever investigation, we need access. Even Amazon can't access the certificate authority that you've put in place in order to generate these credentials.
That is a good point. I hadn't thought of that.
Okay.
Yeah, but yeah, you're right. But where is Let's Encrypt based? I think it's US based. I don't know. So yeah.
I mean, okay, so they need a second subpoena, but my point is that it's like a certificate authority not in the control of the cloud providers. So you've created
that is a good point. That is a good point. Yeah, and in my talk, I stressed twice that you don't have to use Let's Encrypt.
Yep.
This proves that you can use the Acme protocol with any of the other providers or host your own even.
Yeah.
So yeah, that can add another layer of protection if you wanted.
But this Acme protocol was important to you?
Yes, it's open source, it's interoperable.
Okay.
Yeah, I would say so, yeah.
Okay. That's interesting. I mean, if I could push back for a second, I mean, like, it sounds like you found an elegant but maybe complicated solution to a problem that you probably could have solved in an easier way.
I can't disagree with that.
Okay.
But you would either have to bite the bullet and learn how AWS private CA works.
Okay. And then
which is proprietary.
Yeah.
No mind the paying, and then learn those specific APIs and then they tie down to it.
Okay.
Acme was something I already knew.
Okay.
So this was easier for me to get working.
Okay.
So, I mean, if anybody does watch my talk, they will realize that it is really quite straightforward to get Let's Encrypt working with Roles Anywhere.
Okay.
So if you have issued yourself a certificate using CertBot or any other client library like Lego, which was in my talk, it is really very straightforward. If you are familiar with Roles Anywhere and Let's Encrypt separately, this is then an easier way out than even using AWS private CA.
I'm trying to remember now. I can't remember what is the Linux command line command for generate a certificate, but
it's OpenSSL and then 15 arguments to it. Yeah,
right. Yeah, it's been a while since I've had to do that, thankfully, and I don't really miss those days.
No, I did not want to get into all that either.
Yeah,
but the Let's Encrypt has come so far. The client libraries are so mature. They've thought actually about user experience.
So many of these services, I mean, if you think back to the early days of when I was working in IT, and by the way, similar to you, I started in kind of a sysadmin position and you kind of just, cybersecurity was just part of what you did at the time, right? I also had my worst breaches during my time as a sysadmin before I got into more kind of specialized cybersecurity. But that's a longer story. But certificate management was like a nightmare back then, and certificates were very much fixed to the physical, hardware host that you were running on, and, generate these signing requests with like fingerprinting of the CPU at time. And if you ever then had to migrate from server A to server B, that was also a nightmare. Cancel a certificate, reprovision a certificate. Companies were charging thousands of dollars a year for this services, right? I just think about like the economies, the unit costs of certificate nowadays are like darn near zero, right?
Yeah, Let's Encrypt has definitely threatened the models of DigiCert and the rest of them.
Yeah. How have you seen the evolution of certificates over the years? I mean, I look at it and I'm like, this is fantastic. I can put a certificate anywhere that I need to now. I can get a certificate for any service that I need in a matter of seconds, right?
Yeah.
At just like extremely affordable price points. There is the flip side of that argument, which means that like every phishing service can also get a certificate that looks legitimate as well, right?
Yeah. So I think the CA industry has they are at fault with this. They've asked people to trust the padlock in the browser more than the domain name.
Yeah.
And I'm not sure why the browser makers have also decided to now hide away the domain name completely.
Yeah.
Feels a bit wrong that we basically coached other people to just trust the padlock.
Yep.
So, yeah.
Yeah. Kind of a weird evolution of like this trust in user trust on the internet over time, right?
Yeah, there used to be this thing called extended validation certificates. We used to turn the browser bar green. Banks used to have it, and that would require much more validation than just solving a challenge over TCP/IP.
Yeah.
You would have to send your company registration documents to the certificate authority, and they would charge you $500 or $1,000 or what have you, right? And then issue you the certificate.
That's interesting though. If you think about that, right? If you could bring that back to the current internet, which I know would be super challenging because the scale of the number of companies the number of legitimate, valid companies even, put the criminal gangs aside for a second, but just the number of valid organizations that would need to be authenticated and verified with their documents. I mean, that's bonkers already, right?
Yeah, I think it's also the end user education. Well, browsers have only in the recent last few years started removing that feature that the browser bar would turn fully green if this were the case. Or any visual indication of higher trust. But then think about the end user education that, okay, well, if this is green and you can really trust it.
Green means.
But if it's not green, it's just plain. But there's still a padlock. How are you not supposed to trust it? What TLS really gives you is an encrypted channel and a verification of the authenticity. The criminal can also be an authentic person, right?
Authenticity of the certificate, not necessarily of the entity behind the certificate.
Correct. Yeah.
Interesting. Awesome. So wrapping up on the topic of your talk today, so you designed the system, you kind of shared obviously what you built around there. What are some of the key lessons learned that the audience would take away from that presentation?
Key lessons. Let's see. So I think people should be more confident in using asymmetric cryptography in their lives. That definitely, and this because Let's Encrypt is entirely free, all you need to have is a domain name, and people in our industry have 10 or 12 lying about anyway. Never put to good use.
I might have 6 or so of my own ones. And
if you go to something like Pokemon.com, you can get one for $1 or $2 now. So I would say that they should definitely start playing with this. And then learn from experience. Improve their general PKI handling and CA kind of skills. The other one is that the world that opens up with this, because Roles Anywhere literally was made for being able to assume an AWS role outside of AWS anywhere. So all the hacks and the other or vendor solutions, if you will, who were managing this can now go away with this kind of a solution.
But you said something there I just want to make sure I understood. So you said the concept of IAM Anywhere was designed for humans to be able to use IAM roles anywhere.
The concept of IAM Roles Anywhere. That's the full service name of that particular service, right? Was designed to let you assume an AWS IAM role outside of AWS.
Right. But the solution that you designed is for a machine to assume an identity, right? Like, because you're not talking about human transferring log files from your from your service to this GPU provider, right? You're talking about that happening all through automated, I assume, data streams of some kind.
Yes.
Yeah.
But talking about humans, Ben Britt, I'm getting the surname wrong, has recently published a blog post, which was in the cloud security forum Slack as well, where he uploaded the Belgian Citizen Bureau, what have you's CA certificate onto IAM Roles Anywhere. And Belgians are allegedly issued with a citizen ID, which has a private key on it.
Interesting.
So you can authenticate a Belgian citizen into Roles Anywhere now.
Yeah.
That ties it down to a human, right?
Yeah.
Yeah.
I mean, some of these European countries, especially some of the smaller ones like Estonia, I know are doing great things with kind of digital IDs and to your point, using that as a basis for some asymmetric cryptography and authentication access, and then encryption for all the government services and transactions.
So signing should be based off a private key, right? It's like if you open, I'm not going to name websites here, but most popular contract signing services. They just record an IP address and send you a magic link in your email. It's not a very strong kind of legal authentication even.
No, I mean, to be fair, anybody who had access to my email could theoretically intercept any signature request.
Yeah.
Doesn't take a genius to kind of draw something that looks like a signature.
Yeah. And all the best with proving that this IP, and Jeremy was near this IP address physically at the time. Yeah. What does that even mean?
Right. Like, I mean, and there's no reason, for instance, especially if I'm signing on something like, whether I'm signing on my laptop or I'm signing on a mobile device, I've got biometric verification on both systems. It could be my fingerprint on my keypad, or it could be my Face ID on my phone. There's no reason there's not a biometric verification that this is actually Jeremy who's signing this electronic, legally binding.
Legally binding. Yeah. True. So it's just playing with this opens up your mind to these opportunities that, okay, I've got a digital signing key. There's a certificate authority which has issued this to me for a certain reason. How can I leverage this?
Yeah. I want to change gears for a second with a couple minutes left we have in the conversation. I know your background has been in networking and network security. And obviously we talked a little bit about some of the things you learned working in financial services with this kind of parallel network infrastructure, if you will. How have you seen networking evolve over the course of your career? Because to me, TCP/IP fundamentals are still TCP/IP fundamentals. And, things like firewall allow and deny lists are still pretty much the same. Granted, I think the perimeter of the cloud, as far as what is the network perimeter, is a very different thing than the kind of castle and moat classic architecture. But what have been some of your observations?
So pretty much what you said, the management of the perimeter, whether it's your ingress rules or your egress rules, is now very, very difficult to manage.
Yeah.
The meaning of an IP address is not what it used to be, because ownership is by one of these large cloud providers, and they are multi-tenant platforms, and so that has definitely changed. And believe it or not, last year I think 48% of UK's traffic to CDNs was IPv6, so it's finally coming around. It was only 3 or 4 weeks ago I was troubleshooting an IAM policy with somebody on cloud security forum Slack, and it turned out that one of the services from AWS was returning quad A record, which is IPv6. And the other one was returning a regular IPv4 record, and their ISP was already dual stack. So their MacBook or whatever it was had picked up an IPv4 and an IPv6 address at the same time. So it was egressing using both depending on what DNS record was returned.
Interesting.
So the point I'm trying to make is that I am beginning to see IPv6 for real now. So, and that is IPv6 is very interesting because it's globally unique addresses. So I think there will be some loss of privacy because you will be no longer behind that.
So, okay. So when I'm, at home but it's still within my home network, I'll probably have some kind of network.
No, so the IPv6 recommendation is that you'll get a /56 block at home.
Okay.
Each of your devices will have a globally unique IPv6 address.
Even my internal, my refrigerator and
the
devices.
ISPs are particularly interested in the no-NAT aspect because the CPE, the customer premises equipment, becomes a lot cheaper if it doesn't have to do session connection tracking, that kind of a thing.
Okay. So things like your home router and all of those things can become a lot
Just
simpler.
routers, just plain routers. Yeah.
That's interesting. What are some of the key differences between IPv4 and v6? I mean, you mentioned this like /56, and obviously like that doesn't exist in an IPv4 world.
No, it's probably more than the entire IPv4 space that you will just have at home. Yeah.
Sorry, I was thinking like /32 is as specific as we get, right?
Yeah, so DHCP is quite different as well.
Okay.
IPv6 has a method of figuring out based on your MAC address what IP you will get from your 56 block.
Okay.
Yeah, other than that, I think it's just IP protocol. A lot of band-aid that had been put on IPv4 doesn't exist in the IPv6 world.
So like the NATs and the PATs and those types.
Yeah, it's simply not necessary, right?
Yeah. But still things like, fundamental, let's say like subnet masks and route tables and all of those things still exist?
Those do exist.
Okay. Okay. And like the space is much larger, obviously.
Yes.
I don't actually know like how big an IPv6 address is from the standpoint of like how many.
It's 4 times bigger.
Okay.
It's a 32-bit IPv4 address compared to 128-bit IPv6 address.
Okay.
So that does take up a little bit more room in your IP header.
Yep.
And the internet runs on a very low MTU already, less than 1500 surely. So yeah. And it's not an argument against IPv6. I'm just saying that, another 90-something bits will go just into the header. Yeah.
Okay, so this is probably an extra like nanosecond of processing here and there on
which you will reclaim back because of, lack of NAT and the rest of it.
Yeah. Okay. All right. Interesting.
Yeah.
Aside from that, do you still see organizations struggle to manage a lot of kind of network-based rules?
Oh, yeah, definitely.
Yeah. Like this hasn't changed.
This hasn't changed. Yeah. It may become more predictable with IPv6 because people can have fairly stable blocks.
Okay.
So if, like we said a few minutes ago, cloud service providers have to share IPv4 spaces between customers, but there is so much IPv6 space that you won't have to.
Yeah.
In Amazon, if you create a VPC right now, which is IPv6, you get a /56 block for free from Amazon.
Yep.
And that is guaranteed globally unique.
Okay.
Your egress and ingress will both be just that.
Yep.
So it's not the VPC that you spin up today using IPv4, but that is just RFC 1918 private ranges, right?
Yeah.
And the ingress might be shared on that. But that's not going to be the case with IPv6.
Do you think we're at a point where you could actually, like, let's say you were starting greenfield, nothing, no legacy, anything. Could you start something that is 100% IPv6 today?
No. I have already tried. Okay. There's a lot of DNS infrastructure missing to do that still. You will at a point need, the end mile could be IPv6, yes, but you will need at some point a NAT 624, because quite a lot of the world is, the servers are still IPv4.
Okay.
GitHub is a very good example.
Yeah.
They're completely IPv4.
Okay.
IPv6 is on their roadmap, but they don't know.
You want interoperability with a lot of popular services, or you want, let's say, like a lot of consumers in the world, because you mentioned it's like 48%, so that means 52% are still not IPv6.
Yeah.
You want them to be able to access your service. You're going to need this.
Yeah, correct. Yeah, or somebody will have to do NAT 64 on your behalf.
Okay.
Yeah.
Okay. Talk to us a little bit about what you guys are building at Chaser.
We build a network firewall basically for egress. It's like, we talked about IP addresses being shared and so on. So our product is focused on the use of domain names rather than, because, if at a software contract level,
yep,
you are making an API call outbound to a domain name.
Yep.
Nobody gives you IP addresses anymore.
Yeah.
And if they give you an IP address block, it's too big, right, to be comfortable with. Like, Salesforce or something will give you /17.
Okay.
That is huge to be trusted. They've got all sorts of things running in that /17. So, but the last 2 years, we've shifted our focus from the sheer security properties of the product to the usability of the product.
Okay.
Developers don't know what FQDNs or domain names to allow even.
Yeah.
And how to then safely introduce a firewall into an environment where there was no firewall before. So we've developed a lot of logic around dry run mode and alerting, and then how to keep the security team in the loop for approvals, shortening the length of time it would take for a developer to find out they've been blocked to actually getting it approved and unallowed.
Yeah.
So, and I think that's paid off very, very well. When people see the user experience of it, they really appreciate it.
I think this kind of name-based management is likely to be a lot easier for humans than just IP address-based management, which is what we've always had to deal with.
Yeah, it's going to be a problem with IPv6 though, because the addresses are so long, you can't just pick up the phone and say, I'm at 192.168. So that's a problem. But I was coming more from a software contract point of view. If you're writing software to integrate with a third party, what's the contract? You've got the JSON schema or whatever schema is, which is the API contract, right? The way you hit it is also a part of the contract, the URL. And that's hardly ever an IP address these days.
No, that's normally of FQDN.
Yeah. So you can literally put down your contract into the egress rules. Okay, this is where you're supposed to go. This is the third party we are supposed to trust.
Yeah. Makes a ton of sense.
Yeah.
Awesome. Dhruv, thank you so much for taking the time to join us. For having me. Awesome. For our audience, thank you for joining us on this episode. If you know somebody that you think we should have on the show, please reach out. If you or somebody that you know wants to come on and join our Breach series and share real-world experiences, we are still looking for a couple people to join us on that series as well. Otherwise, on behalf of myself, on behalf of Dhruv, thank you so much for taking the time to join us on Modern Cyber. Talk to you next time. Bye-bye.